Hello everybody and welcome to our today's webinar. My name is Stefan Berger. I'm Area Sales Manager for the European market, and together with my colleague Matthias Tanzer, Head of Project Engineering Department, we will present you today our newest development, the one with one production cell control. If you don't have full screen mode yet, please just double click on the browser. That should work out, that you have a good view. And also please feel free to ask questions. Just use the chat function, and at the end of the webinar we try to sum up and answer your questions accordingly. Today we will explain you how did production cells looks like in the past and which possibilities do we have nowadays. Also, how is it possible to have only one control for the whole automation cell? How does it work from the hardware side and from the software side? What are the core functions of the MAP.commander CC? My colleague also will introduce some projects what we already realized together with our customers, and we will present you also our new portfolio of our MAPLAN robot systems. At the end of the webinar, we will also try to answer your questions. And yeah, let's move on. The MAPLAN one-stop shop. We were thinking quite a lot of time now because market is changing, requirements are changing on the market. Labor costs of our customers are increasing. The operators are not available anymore, and there is a huge pressure. So our customers need to provide 24 hours stable quality of production, and this is only possible if you head in the direction of automation. So we took the possibility, we built up our new, let's say, department, which is led by Matthias, and they are responsible for planning those automatic cells also in combination with application engineering. And also, which is coming more and more, that customers, they want to have the project out of one hand. So the responsibility is 100% from the supplier, which is in that case MAPLAN. So in the past, as you know, we were building injection molding machines. We're still doing, but we only had some, let's say, semi-automatic options like shuttle systems, mold runouts, and simple brush devices for automatic process on horizontal machines. Nowadays, more and more, it's all about robotic, introducing robotic systems, linear axis, feeding systems into the whole automatic cell. And what is also important to us is being able to influence the process really into deep is that we introduced our MAP CRB systems. Matthias already presented it in the last webinars. This is very important for us to really also influence the process, and with this we can really supply you the whole system. In the past it looked like this. We had the MAPLAN machine, we had a separate automatic cell with an independent control, and in between we had to let's say establish for every kind of cell different interfaces. Most of the time it was digital interfaces like the UMAP interface, all the time different, a lot of wirings, and especially special softwares. Yeah, so every kind of machine had a special software, looked in a different way, so it was most of the time a big mess if you want to do an update in the future. So we were talking to our customers and asked them, look, what could we do better? What could be the added value? And out of it, we decided together with our software engineering department to create a control which is called MAP.commander CC, where we not only control the machine, but also the automation components, as you can see here. The big benefit of it is, so you have the MAP.autocell, which are the components, all hardware, so the machine, the linear axis feeding systems, and also the security. And you have the mastermind, which is the MAP.commander CC control. It works like this, or let's say our target was to really give the operator the same overview as they already know from our machine control. So they are able to program the cycle in the same way, cycle configuration, very flexible build up. You have the monitoring during the production and the diagnostic. Of course, the documentation, the page help function in the same way like on the machine. And also you have the same remote possibilities like online remote. You're able to access your machine from your computer, even on different plants all over the world. And we can support you also per remote service. How does the signal exchange works? With the MAP.commander CC, we have a central APC, a computer, which is then communicating with the machine or machines, several kinds of machines, up to 6 pieces. The machine themselves has a standard software, and the APC with the special software is communicating via OPC-UA with these machines. Also with conveyor belts, the safety cell, insert preparation, and robot system, so the whole periphery. How does the screen look like? On the right side, you see very well, this is the machine control in orange. And on the left side, you have the automation control with the new color. And you can just switch from on the panel between the machine control and the automation. You can do this directly on the machine, or even if you have access online over the computer, you can switch between the machine and the automation. Of course, you can also have several panels on the machine. Normally, you have one panel directly on the injection molding machine for setup and mold mounting, and you have another panel at the automation station outside where the operator is checking the parts, for example. Yeah, some pages, how it looks like in our control. On the left side, for example, you see a SCARA robot. As you can see, you always have the real status visualized of the robot, in which condition is he working at the moment. On the right side, for example, this is a preparation turntable system, what we programmed for a customer, even with a cavity shutoff system. So customer requirement was, if a cavity is damaged, you can deactivate in the software one cavity, and all components in the system know, everybody knows that this cavity is not activated for the next shot. Troubleshooting was a big topic in our development. We really wanted to give the customer the added value that with one view, he can see if a problem appears, what's going on. Yeah, where is the problem? Where is it located, and how can I solve the problem? So you have the same alarm overview as you are well known from our machine control. You have the diagnostic, and you are also able to, for example, move a linear axis into the starting position only with pressing one button and not running around between 2 different control systems. So that was my part about the MAP.commander CC, and now Matthias will take over and present you our new portfolio about the MAPLAN Robotics system.
Okay, thank you, Stefan, for the first slides and the basic informations regarding the MAP.autocell and the MAP.commander CC6. I would like to talk a little bit about robotics. Robotic is a big topic in such a cell around the production area, and for the robotic side, we had a long discussion with different robotic suppliers, and in the end, we found with company Stäubli a perfect partner which fits perfectly to your demands in regarding the elastomer production cells, and we created the MAP-Mate series. That means the MAP-Mate series means the integration of the full Stäubli robotics portfolio in the MAPLAN world. What are now the benefits or the key facts for this MAPLAN robotics? On one hand, with these robotic systems, we have high precision systems. We have a long lifetime of all components, beginning from the robot arm, the control unit of the robots, and also the end of arm tooling of such a robot. We have also a low maintenance costs and low maintenance of the robot arm and also the gripper system, and we have it completely integrated in your control unit. What means completely integrated? We have the Stäubli CS9 control unit in your MAPLAN electric cabinet, in the cooled electric cabinet, and we have it integrated in the control unit. That means you have to teach the starting positions one time with the teach panel of the Stäubli robot, and then you can control the robot and all functions and all alarms directly on the MAPLAN control unit. This enables a 24/7 production in combination with the cell, and increased therefore the output. You have a very safe use because no person has to go inside a security area in front of the machine or behind the machine, and you have elimination of a staff-intensive task when you use such robot systems. As I said before, we implemented with the name MAP-made the Stäubli Robotic series. We have two series. One series is the MAP-made 6X robot series. It's beginning from MAP-made 40 up to MAP-made 200. This robot type is used normally for plate handlings, for machine loading, machine unloading, demolding process, but also for spray applications or cleaning applications with a special gripper system. Payloads are beginning from approximately 2 kilograms up to 130 kilograms. We have a second MAP-made series that's called MAP-made SCARA. It's for ultra-fast demands. We have here the SCARA types 40, 60, 80, and 100. It's have a payload of about approximately 8.4 kilograms and a reach of 460 to 1000 millimeters. Now I would like to hand over to Stefan again, and he is presenting some projects we have realized in the past.
Yeah, we are really happy to show you also some projects we already realized together with our customers. The first project is about the fully automatic production of milk liner systems. Maybe you heard about it from the milking industry nowadays, or in the past was mainly produced manually or semi-automatic. And together with our customers, we developed the system to have a possibility for fully automatic production, but still having the possibility to have different kind of compounds, or let's say what we achieved, having in one mold, in one mold, different kind of cavities, so different kind of lengths and measurements of the milk liner systems. So now we're going to show you a video where we're going to explain the main components of this automation cell.
We are standing here in front of a fully automatic production cell based on a MAPLAN ERGO+ 400. With this cell we are producing parts for the dairy industry in a fully automatic way. The main component of the cell is a ERGO+ 400-ton vertical injection machine. We have a bottom closing clamp system, and on the top we have a MAP Pfeiffer original injection unit with a volume of 2.6 liters. In the rear side of the machine we have the automation components, and we have the possibility to change the operation area to the front, and then we have on the front a manual operation area with a light curtain and a safety gate in a switchable version. Normally for the automatic way we're sliding the core blade out to the automation side on the back side of the machine, but we have the possibility to change the frame shifting to the front of the machine and have here a manual demolding of parts. One of the key components of this cell is the 18-volt demolding unit. We have this automatic demolding unit on the rear side of the machine, and in combination with the robot we have here the special thing that we have a wide range of different articles. We have 18 different articles in one mold and can demold 18 different articles in one step with this demolding unit. The cell is equipped with a product of the MAP-made 6X robot family. This product is a MAP-made 90. In this case, this is equipped with the end-of-arm tooling for cutting the sprue from the parts, gripping the parts, and gripping the sprue. The cell is equipped with two MAPLAN control units. In this case, I'm standing in front of the automation panel. On this panel, you have full access to all automation components around the cell. Each of these control units, one for the automation cell and one for the machine control, has its own automation PC. And on front of the machine, I have a second panel, which I have full access to all machine configurations and all machine movements. You see a very interesting and challenging project from MAPLAN side and the customer. We achieved that we have here limited the manual demolding work to a minimum and increasing the efficiency of your customer to produce these parts in an automatic way. Very sorry that we cannot show all components in detail, but this is due to protect the know-how of your customer.
We also made an interview with our customer and asked them about the added value in their point of view, what they have now with the MAP.commander CC and the MAP.autocell.
What was in the end the crucial decision factor to purchase the complete system from MAPLAN?
Delaval has operations all over the world, and it's important for us to have the service and support wherever we are. With MAPLAN, you have entities in Europe and in the US, which is where we need that support. So for training, spare parts, service, all of that is available from MAPLAN, and we don't have the same results from every other supplier.
So Jeff, you are director of the project management office. How would you rate the cooperation with MAPLAN between the project implementation phase and the planning phase?
From the inception of the project, MAPLAN was working really well with us because with MAPLAN's experience in rubber injection machines for many years, Delaval has its own experience with injecting our own product. So with that, we know that we bring the two experiences together, and MAPLAN really listened to us to understand what we needed on the demolding system. So I think it's important to know that we had very good communication, very good project activity, and very good meeting structure to make all of this happen.
What do you see as a unique selling point of the MAP.autocell?
Okay, as far as a unique selling point, I think a little bit attached to the last question was that MAPLAN heard what we wanted to do with the extraction of liners. We've had prototypes of this kind of system for many years now, and MAPLAN has taken the prototype that we have and actually industrialized it in a good way and attached it to the equipment for automatic extraction. We think we have an absolutely unique system to do the liner production in the best possible way.
So the complete system is controlled by the MAP.commander CC cell control. Do you see any specific advantages in this control for the operation?
I think, Martina, what I really like is the fact that you have a cell controller and you have a machine controller. They talk to each other, and of course you can switch controls between the two functionalities, but it gives the operator the ability to see what's happening on the demolding unit, in our case, versus the machine control. So they can look back and forth between the controls, or they can look at one control and do the whole job. So it's very flexible from that standpoint.
Thank you so much, Jeff, that you have been available for us for the interview. It's been great to listen to your insights.
It's my pleasure to be here, and thank you for staying here this evening with me. And thank you from all of Delaval, and especially the Chillicothe team that will enjoy the benefit of these new machines.
Great, thanks a lot.
The next project, what we're going to present to you today, is a fully automatic production cell for production of seals for brake systems. It's a rubber to metal bonding article, very small one. And the challenge was to really coming from the small parts, from the metal parts, making the whole feeding, the loading of the metal parts to the mold, unloading, and also checking of the parts afterwards. Now we're going to show you a video also how this system and this cell is built up.
Welcome here in our technical showroom. Behind me you can see a full automatic production cell which produces rubber metal parts for the automotive industry. The parts take a critical role in the safety of truck braking systems. The cell is based on a vertical injection molding machine out of our Ergo Plus range. The machine is a bottom clamping model, fully hydraulic with 160 tons of clamping pressure. It's equipped with a MAP FIFO original injection unit with 700 cubic centimeters volume. Additionally, we equipped the machine with a parallel hydraulic system which allows simultaneous movements and therefore optimized cycle times. The first task the cell has to handle is the separation and preparation of the metal inserts. The inserts are delivered in bulk and have to be handled with as much care as possible since they are coated with a bonding agent. Therefore, we use a flex feeder system paired up with a vision system and a SCARA robot, which take care of the handling. The parts are separated and their location is detected. If necessary, they can be flipped around with these two grippers, and then they are put onto the preparation plate where the handling can take them and load them into the machine. The main actor is our inserting and demolding gripper. It's carried by a 2-axis linear system which is servo-driven. It consists of 4 individual gripper units which handle the tasks of demolding the finished parts and sprues, as well as loading the metal inserts into the mold. At any point of time, each individual part is monitored for presence, and so we can detect any issues as soon as they appear. After demolding, the finished parts are placed onto 2 servo-driven conveyors and are handed over to the quality control station. The handling of the parts is done by several pneumatic handlings, which place them onto a rotary indexing table. Each part is shifted under a visual inspection station, where they are tested for quality. If necessary, they are separately moved out of the cell by this handling and separated into bed and manual control parts. Good parts are placed onto this conveyor and are brought out of the cell to the post-process. To handle all these tasks, we have paired our well-known machine control, MAP.commander C6, up with our specially developed automation control, MAP.commander CC6. On this cell, we have mounted 2 operator panels, one of which here is directly mounted to the molding machine and dedicated for the molding machine. And the second panel is dedicated to the automation, which is mounted here on the side. Here we can see the operator panel for our MAP.commander CC6. The software was developed for flexible use and was equipped with special models which are fitted perfectly to the application. In addition, we have the possibility to operate the automation control from the molding machine panel. By the click of a button, I'm able to open the visualization of the automation control and use its full functionality. You can see we were able to develop a highly specialized cell for our customer, which is fitted perfectly for their needs and their use. This all wouldn't be possible without perfect cooperation between us, our customer, and our system partners. For that, we want to thank them.
In the next interview, the project leader of our customer, Christian Huber, will explain to us why they chose for MAPLAN, what was the benefits in his point of view, and how was the realization phase together with MAPLAN.
Herr Huber, Freudenberg Sealing Technologies Austria hat ja schon zahlreiche Projekte mit MAPLAN als Technologielieferant durchgeführt. Einerseits für Spritzgusstechnologie, andererseits für Automatisierung. Wie kam es, dass diesmal eine Gesamtlösung angefragt wurde?
Also die Situation ist die, dass unsere Kunden immer steigendere Anforderungen haben. Die gehen wir natürlich als Lieferant mit und somit stellen wir auch die höheren Ansprüche zu unseren Lieferanten. Und die Firma MAPLAN kann eben als Spritzgusshersteller nicht nur die Spritzgussmaschine liefern, sondern auch das Komplettpaket. In diesem Fall umfasst es eben Spritzgussmaschine, Automatisierung und auch ein komplettes Werkzeugsystem. Und die Vorteile sind hier einfach die Komplettabwicklung mit einem einzigen Lieferanten, der dann alle Sublieferanten koordiniert und uns dann als Endkunde und Betreiber der Anlage eine Gesamtanlage zur Verfügung stellen kann. Und das waren dann die Gründe, auch in Richtung der Komplexitätsanforderungen, die MAPLAN sehr gut überzeugt hat und uns dann zu dieser Entscheidung geführt hat.
Welche Anforderungen stellen Sie an die gesamte Produktionszelle?
Also die Anforderungen, die wir stellen, sind genau im Lastenheft beschrieben. Das ist einmal als erster Punkt die genaue Umsetzung der Gegebenheiten wie Ausbringungsmenge, Zykluszeit etc. Der zweite Punkt ist, dass die Qualitätsmerkmale erfüllt werden. Das heißt, dass die Spritzmaschine sein Leistungsspektrum erfüllt, aber auch, dass die Automatisierung die Teile fehlerfrei und ohne Beschädigung durch den gesamten Prozess durchschleust. Und drittens und letztens, dass die Gesamtqualität des finalen Produktes auch erfüllt wird, die wir dann an MAPLAN stellen.
Okay. Was war ausschlaggebend, das Gesamtsystem von MAPLAN schlussendlich zu nehmen?
Die größte Überzeugung war dann die, ein Gesamtkonzept von einem Lieferanten zu bekommen, im Sinne von diesem Turnkey-Projekt, mit dem großen Vorteil, dass wir eben die Spritzgussmaschine und die Automatisierung als ein Stück haben mit einer gemeinsamen Steuerung. Bis jetzt war es so, dass wir immer die MAPLAN mit einem externen Automatisierungspartner separat zusammengeflanscht haben und dann war immer die Schnittstelle Steuerung MAPLAN und extern automatisieren mit einer SBS. Und da gab es dann meistens Probleme oder Schwierigkeiten in der Kommunikation. Und der große Vorteil, der dann schlussendlich die Aussage da geliefert hat, war ein Hersteller, eine Steuerung, ein System, ein Gesamtsystem.
Bleiben wir gleich bei der MAP.commander CC Cell Kontrollsteuerung. Welches Feature oder welcher Benefit ist für Sie dabei am ausschlaggebendsten in der Produktion?
Dass eben eine Steuerung beide Anlagenteile betreiben kann. Wir können sowohl von der Spritzgussmaschine aus auf die Leistungsdaten der Automatisierung zugreifen und auslesen, aber auch von der Seite der Automatisierung, wo unser Werker steht oder die Werkerin und die Anlage betreibt, ist in der Lage, auch die Informationen der Spritzgussmaschine auszulesen. Und somit können wir in beide Richtungen simultan arbeiten und ist somit ein reibungsloser Betrieb möglich. Und auch bei Stillständen, Neuanfahren oder nach Pausenbetrieb kann jederzeit von beiden Seiten die Steuerung angefahren werden und es können somit erleichterte Bedingungen für die Betreiber geschaffen werden.
Herr Huber, was ist für Sie ein Alleinstellungsmerkmal der MAP.autocell?
Das ist der große Vorteil, den MAPLAN uns als Kunde bieten kann, nicht nur ein System, also die Spritzgussmaschine alleine, sondern ein Gesamtsystem anzubieten, jetzt eben auch mit dieser Autocell-Funktion. Und hier kann dann auf den großen Erfahrungs- und Wissensschatz von MAPLAN zurückgegriffen werden und auch dem Netzwerk seiner Partner und ganzen Lieferanten, wo dann genau die zielgerichtete Lösung gefunden werden kann, die wir benötigen als Kunde.
Darf ich Sie noch fragen, wie war die Zusammenarbeit mit MAPLAN in der Umsetzung und Projektierungsphase?
Es war eine sehr spannende Zeit, denn wir haben es in einer sehr kurzen Bearbeitungsphase entwickeln können. Es war vielleicht auch mal etwas turbulent, aber im Ganzen war es immer eine spannende, faire, offene Kommunikation. Man wurde ständig über alle Fortschritte informiert und es wurde immer auf Augenhöhe kommuniziert und von dem Ganzen her kann man eigentlich nur Positives darüber berichten.
Das freut uns sehr. Vielen Dank für das Gespräch, Herr Huber.
Bitte sehr gerne.
So what are the real advantages of a MAPLAN production cell? First thing is you save a lot of time because we take care about the realization from the idea, from the part drawing, to the realization and to the finished product. We will guide you from the beginning to the end. All cell components, starting from the machine to the automation, of course also mold, are perfectly synchronized and well organized. We will support you during the startup of the production, in-house acceptance trial at MAPLAN, and also after the installation on site. We have one contact person for all the concerns and components. This is really important that we have one project leader internally, and he's the mastermind of the project. And with our MAPLAN premium technology partners, we are also able to reduce engineering costs and have a shorter implementation phase compared to if you have to take care about everything and discuss with different kind of partners. We'll hand over to Matthias, which will explain also the support possibilities we have with the MAP.commander CC.
Now we heard a lot of basic facts about the control unit and the components and see some sample projects, but how can MAPLAN help when you have such a cell in production and maybe you have a problem? We can help you with remote service. That means we have remote assistance by the MAPLAN support team. This is powered by the Telelook system or by MAP.i online cam. We have a remote diagnostic for soft and for hardware. This is the same as on the machine side, but now we can also give you the advantage that we have full soft and hardware remote access to all components which are integrated in the automation cell. We can help you with finding the right settings on the cell and can change it via remote access. We can activate or deactivate software features over the MAP remote way, and we can give you first or second level support for the complete cell, machine and automation components.
Thanks, Matthias. As promised at the beginning, we collected some of your questions you wrote in the chat function, and we're going to try to answer them as good as possible. Thanks, Martina. Okay, are MAPLAN technicians trained to program and service MAP.made robots?
Yes, of course. We have trained technicians in the technical department for simulations, and we have trained persons in the service department to program the MAP.made series, yes.
Excellent, I think question answered. Is it possible to connect to the MAP.commander CC via computer for monitoring and support?
Yes, we have the same feature as you know on the MAPLAN injection machine. So you have remote access to the APC of the machine control, and you have also on the same way the access on the APC for the automation components.
And the last question was, how long does the quotation and engineering phase take?
Okay,
interesting question.
That is an interesting question. This is not clearly answered because it's depending on the demands on the cell. So we need a few weeks to get this quotation step by step. Then we can give a budget price, then we can give a final quotation, and then we have a realizing time over a few weeks. Maybe a middle value is around 30 weeks for realizing a project from the quotation phase when it's finished to the first trials in-house at MAPLAN Austria.
Agreed. Okay. Gentlemen, I hope you enjoyed. I hope you could take something out of this webinar. We could, let's say, gain some interest, and maybe we can set up such a project together in the near future. I also would like to invite you to our next webinar, which will take place next Thursday to the same time. We will discuss about hidden tips and tricks of the MAP.commander control. And yeah, for now, thank you a lot for joining. Stay tuned also on LinkedIn and on Facebook. And enjoy. Have a nice day. Thank you.
Thank you.
Bye.